let's look at today's learning goals. I can represent proportional and non-proportional situations. I can represent non-proportional situations using a table, graph, or an equation. I can explain the differences between proportional and non-proportional relationships when given a table, graph, and an equation. And I can write an equation from a table of data, a verbal description, and from a graph. All right, so we're going to cover 3 things, and it is STAAR review number 3. Last one for this week anyways. So let's get to our notes. Non-proportional. Now yesterday we were at proportional. Today we're at non-proportional situations. Can be represented by tables, graphs, equations, and word problems. Non-proportional graphs will not contain the origin. Okay, so they're not going to go through the origin. We all know on a 4-quadrant graph, the origin is here. Okay, on a 1-quadrant graph, the origin is here. So whatever line is there, it will not contain it. Okay, it will be somewhere different than going through the origin. And sometimes, most of the time, it will still be straight. In 8th grade, your lines are generally straight. The only types of times when we see lines that are not straight is when they're talking about questions about functions. Okay? Non-proportional equations in word problems. So we've gone over graphs. Word problems. In the form of y equals mx plus b. I hope today I left you another mathematics chart out. And I hope that you filled out the parts that we've gone over so far. And that would mean that you should have what is this kind of an equation? You should have an NP here, and you should have a P here. And this is for what? Slope of a line, okay? M. I don't know. Maybe we want to build the habit because I don't see enough of you writing. If you'll write slope, okay? So if you're looking for slope, that is the equation that you need from a table, okay? So we are looking at the ones with a plus or minus b. That's because proportional, it was a plus 0, which we just leave off because we're lazy. So a plus or minus b means it's not going to include the origin, okay? So here it is. Y is the total. M is the slope or rate of change. And B is the y-intercept. So this is your y-intercept, and it will not be 0. The situation always has addition or subtraction. Okay? It will always have that. The B value, the y-intercept, is a one-time event. So things that are one-time events, when you're looking at word problems, an initial value, a membership fee, an initial height, like examples for rivers or airplanes. The airplane started at 3,000 miles in the air. Beginning temperature, okay? So it's a starting point. These are just some of the things that I've seen used, all right? Flip over. Let's go over some examples and how we're going to work these. It says, which table identifies the points on the line produced by an equation y equals 6x minus 4? Now, there are 2 ways you can work this, okay? I just seem to think that if you're given a table of values and an equation, or a table of values and 4 equations, okay, which you can do, to me, to find the slope and y-intercept on these, it's, first off, I don't see where x is 0 on any of these, so obviously we don't know what the y-intercept is. We can't identify it right from the table. So for me, guess what's the easiest way to figure this out? I'm going to go to Windows, and I'm going to set my windows. Negative 100, 100, that's a 1, negative 100, 100. And you notice when the x minimum is negative 100, y minimum is negative 100, x maximum is 100, y maximum is 100. And I'm going over some things that some of you, I know you know, so please bear with me. But this is my last chance to say these things. Then you hit second and quit to get out of that screen. I'm going to go to y equals. And I'm going to put this equation in. Y equals 6x subtract 4. Now, I'm looking at tables, aren't I? So I'm going to hit second, and in blue, it's a table. So remember that you can arrow up on this table as much or arrow down as much as you need to. And in the left column is your x values, okay? So I have in A, x is 2. So let me find where x is 2. Y is supposed to be 2 if it was A. That's not correct because the equation I put in here was correct, so it does not match A. Here's 2 and 8. Now we need to make sure it all matches. 4 and 20. 6 and 32. And 8 and 44. That was just too easy. Isn't that easier than doing y2 minus y1 over x2 minus x1, finding your slope? Then you would have to back out to find your y-intercept because there is nowhere x is 0. So in other words, this is going x is, and I'm going to show you, I'm not even going to show you the long way. It's just too complicated, and this makes it just so much easier, okay? Let's look at a word problem. As part of a special offer, Sandra's bank gave her $100 to open a new savings account. So they gave her $100, didn't they? Remember, I'm trying to solve y equals mx plus b. Okay? B may be 0, but that would mean that the y-intercept you start out with 0. So they gave her $100, which is a one-time thing. Sandra plans to make deposits of $25 into the account monthly. So do you see that? $25 monthly, okay? Assuming Sandra makes no withdrawals, which equation best represents the linear relationship between x, the number of months, okay, so that's going to be your x, number of months, and deposit Sandra makes, and y, the total amount of money in the state. So it's a bunch of migwara. I know she has $100. I know she's going to make $25 every month. So which one matches? It says y is the total. So remember I said in 8th grade math, you're never going to have an x equals. So it's going to have to be D. Okay? All right, let's look at number 3. Which graph represents the linear function y equals 2x plus 5? Okay? Well, if I put y equals mx plus b, there's a couple ways I can do this. Okay? First way is I know that my b or my y-intercept is 5. So I've got y-intercept of 5, I've got y-intercept of 5, I've got y-intercept of 5, I don't like that one, it's not a y. D, and I'll bring it up so you can see it, is not a y-intercept of 5, so I can mark D off. Okay? The next thing I know is that my slope is 2. Well, remember, slope is rise over run, which is 2 over 1. Okay? So I can sit here and start, but remember, look at this. These are going up by 5s. These are going over by 1s. What are these doing? 5s and 1s, 5s and 1s. At least they were consistent on this one. And I'm going to get in here real close and look at each one of these graphs. That made it kind of look a little, see if I can focus this. It's not my normal camera, so see if I can focus this a little better. So I'm rising by 5, so I need to pick 2 spots. I've got this spot, and it looks like I can count this spot. So I'm going to write rise over run, and I obviously have a positive line. And if I go up 5, 10, because that's where I would go up 10, counting by 5s, and then go over, they're going by 1s, 1, 2, 3, 4, 5, okay. I would find, what is this? 10 divided by 5. Let's see what that is. So second quit on here. 10 divided by 5 is actually 2, and that's what I needed. So that would give me a slope of 2. So I would choose A. Okay? I'm going to show you another way to do that. Okay? Another way would be this. Go back to y equals, put in your equation, 2x plus 5, okay? And hit second and table. And I'm going to look for some points, okay? And I'm going to use a different graph because I want to show you some points here. I've got, let's say that this is 5 for my y and 0. So this would be 0 and 5, okay? Then another point I can see clearly is right here, okay? And that is 2 and 10. Let's see if that matches up. 0 and 5 does, but 2 and 10 does not. Do you see that on my calculator? I went to second and table. 2 and 10 does not. Let's look at this one. 0 and 5 matches up, and I've got 2 and 10. Well, that doesn't match up either. Let's look at this one. 0 and 5. Now, see, it's not really next to the 2 and 10, so I'm going to go all the way over to where that 5 is that I chose. And I'm going to come down here, and it says 5 and 15. And do you see x is 5 and y is 15? So here's another way to solve a problem like this. Okay? Just saying. Let's look at some of your problems in your paper. I see pretty much these are the same. Number 4 might be a little tricky because of these halves. All right, so be a little wary of those. Number 5. Now see, when you have a table and you have a graph, why don't we just do this? This one right here, okay? So number 4, we're going to do number 4 together. The original way you would do is you would know that this is your x, so this has to be your y-intercept, okay? And I'm not going to say, you know, the answer's there, whatever. Then you would have to pick 2 points, and you would have to pick the 2 in the middle, and you would do x1, x2, y1, y2, okay? And you would have to do your y2 minus y1 over x2 minus x1. What I'm saying is go through your equations. It's so much easier. So the first equation I have is 0.5x plus 0.8, okay? And I'm going to hit second and table. When x is 0, y is 0.8. Does that match this table? No. So I know it can't be this one. Let's go to the second one. Clear it. 1.6x plus 9.75. And let's hit second and table. When x is 0, y is 9.75. When x is 1, y is 11.35. When x is 2, y is 12.95. Is that 12.95? Yes, it is. So guess what? I have found my answer. All right? And that's how simple it is if you can learn how to use this calculator to help you solve problems. So number 4 is B. Okay? And here you're just finding your rise over your run. That's going to be your slope. Remember, you're filling out y equals mx plus b. You could also do it by putting each one of these in. If you recognize that where your y-intercept is, you could probably knock one of them out. And then you could look for points if you wanted to. Here, we're looking for the same thing. You're given one equation, and you're trying to find which one matches that. Okay? So, let's see. Here, they just want you to recognize which equation is non-proportional. Okay? That's pretty easy. So I think this is pretty straightforward. Have a great day. Bye.